Okay, hey students, welcome to the final lecture. So let's just jump right into it. Um, this class we're going to be learning the basics of how to analyze our class data and analyze some other data sets as well. Okay, so there's a couple of things that I want to talk about. First of all, I want to go over some basic terminology that is helpful when you're working with data. I want to talk about some different types of variables. And then we're going to discuss two techniques, cross-correlation and, cross-tabulation and correlation. Okay. Okay, so to begin with, some terminology. So um, whenever you open a data set, the first thing that you want to do is to identify the unit of observation of that data set. And the unit of observation is simply what a given row of the data constitutes. This could be a person, a firm, a year, a country, anything really, okay? But it's whatever each row of the data constitutes. So for example, okay, in our class data set, each row of the data represents one student in our class. So you would say that the unit of observation of this data set is a student or maybe a person or individual. Okay? But this varies depending on the data set. For example, have a look at this country statistics data set. So in this data set, the unit of observation is an individual country. All of these variables here going across are variables that pertain to that country. Okay? What about this one? This data set is some data from the S&P 500. And you can see what this is well, have a look. This is 1947.01, 1947.02, and notice it goes all the way to 1947.12. Okay, so what these are different months, okay, in the year 1947. And so the unit of observation of this data set is a month, okay, because each row of the data corresponds to one particular month, okay. Let's just do one more example. Let's have a look at this loan apps survey. Okay, so this loan app survey refers to whether individuals, this is data on people who applied for a loan, and it tells you whether or not they got the loan that they applied for. Okay, so again, each row of this data set represents an individual. Okay, so those are examples of units of observation. Okay, so now based on what the unit of observation of a data set is, we can classify all data sets essentially into one of three types. Okay, the first is cross-sectional, the second is time series, and the third is a panel data set. So let's look at an example of each one of these. So most of the data sets that I have here in our little Excel sheet are cross-sectional. And a cross-sectional data set has variation, basically, it does not have any variation in time. It just has variation across individual units of observation, whatever that unit of observation is. Okay, so for example, our data set is a cross-sectional data set because we just have variation across students. Okay, and the same is true of most of the data sets here. Now, on the other hand, if we have within our data variation across time, but no variation across individuals or across units, then what we're dealing with is a time series data set. So for example, this S&P 500 data set, you can see that this is only dates going down. The unit of observation is just a unit of time, but we don't have any sort of cross-sectional variation within that. So for example, for a given date, it's not like we're looking at, the value of like 5 or 6 different stocks or something like that. Each of these variables over here is just specific to that particular date. Okay, so this is a time series data set. It contains variation only across time. Okay, now you go, so what is the alternative to either of those? Well, you could, in theory, have a data set that has variation across both units or individuals and across time. Okay, and that is known as a panel or longitudinal data set. So for an example of that, have a look at this National Survey of Youth, okay? So you can see in the National Survey of Youth, if you were to ask yourself, what is the unit of observation of this data set? There are actually sort of two units of observation, okay? So first of all, on the one hand, we have this variable ID, okay? And you can see what's going on with this ID is this basically corresponds to an individual unique person. This is like the person's name, if you will. Okay, so here we have individual 4, but you'll notice that that is repeated a number of times. Why is it repeated a number of times? It's because this person was asked these questions across a number of years. So you can see for each person, we have variation. We have that person's responses for the years 1981 through 1987. Okay, and so this data set has variation across both individuals, and for each one of those individuals, it has variation across time. So this is known as a panel data set. Okay, so let's talk about then some types. So those are different types of data sets. Let's talk about some different types of variables that we might find within those data sets. The first and most fundamental distinction, okay, is usually when you're examining a data set, you're trying to look for a relationship between those variables. And you're trying to look for really like a cause and effect relationship between two of those variables in question. Okay. And so the variables that we're viewing as the cause of that relationship are known as the independent variables. And the variable that we are viewing as the effect would be the dependent variable. Okay. Now, this is up to you. Okay. As the person examining the data set, you get to choose what the independent and the dependent variables are, but certain variables just make more sense as an independent variable, while others make more sense as a dependent variable. Okay. So for example, if you were analyzing our class data set, let me go back over here. Let's say that you were interested in analyzing our class data set, okay? And for example, let's say that you were interested in understanding how a person's gender, okay, affects their college GPA, okay? Do guys in the class get better grades, or do girls in the class get better grades? Okay, well, in that case, you would be trying to understand the cause and effect relationship between your gender or your biological sex and your GPA. So in that situation, you would be viewing sex as the independent variable and college GPA as the dependent variable. Okay. Okay, so that's one way in which we can classify different variables within our data set. Okay. Another very important way in which we can classify these variables is to distinguish between a continuous variable, what's known as a continuous variable, and a categorical variable. Okay, so let me explain what that means. So a continuous variable is a variable which can take on a large range of possible values. Okay, so for example, college GPA and high school GPA in our data set are continuous variables, right? Because think about it, they could, I mean, if you were to list all of the different unique values, well, there would be potentially, tens or even hundreds of these, right? It could be 3.5, it could be 3.1, it could be 4.12, 4.13, etc., right? So that's a continuous variable. Some other examples of continuous variables, somebody's wage is a continuous variable because your wage could pretty much be anything. It's a very large range of possible values. Okay, the value of the S&P 500 on a given day, that's a continuous variable because it can take on a large range of possible values. Okay, now the opposite of that would be what's known as a categorical variable. Categorical variables can only take on a small range of possible values. So for example, in our data set, sex is a categorical variable. It can take on only one of two values. Okay. Well, I suppose if this was gender rather than sex, and we were looking at gender identity, there could be more than two. Okay. But same thing with year in the school, right? There's really only four possible values for that. Well, five if you count like a super senior. Okay. and in fact, you see that most of the variables in this particular survey actually are categorical variables, variables that can take on a relatively small number of possible values. Okay, and in particular, this is just an additional point of terminology. If a variable can take on only two values, like sex in our data set, or like, for example, I asked about have you ever tried an illegal drug? There were only two possibilities, or actually technically, sorry, that's a bad example because there were actually three alternatives for that one. I added in I did not inhale as a joke answer. Okay, but let's look at, are you currently in a relationship? Okay, so that one only had two possible choices, yes or no. Okay, and so that would be considered a dummy variable. Okay. Okay, so that's just some basic data terminology. I hope all of that makes sense, and then I'll see you guys in the next video.